SOH CAH TOA is pretty straightforward, actually. I can just give you a quick overview. SOH CAH TOA. So this is sine, which is equals to the opposite over the hypotenuse. This one's cosine, which is the adjacent side over the hypotenuse. And the last one is tangent, or just tan. That is equals to the opposite over the adjacent, right? Like these letters represent what they stand for. Like A is adjacent, H is hypotenuse, O is opposite, A is adjacent. We can just do a couple of questions here. Let's say we have a triangle, okay? And these you can only use when it's a right angle triangle. If it's not a right angle triangle, then you have to use something called sine law and cosine law, which is a little bit more difficult, but I don't know if you're gonna see that just yet. Let's say the angle is 30. Let's say the opposite side, the side that's facing the angle, let's say that is 2 units, okay? The question is find x, the hypotenuse. So now how do we do this question? So first, look at what they've given you. They've given you the opposite, right? And then you're looking for the hypotenuse. So these are the two variables of interest for you. Which one uses the opposite and the hypotenuse? It's going to be sine.
The first one.
Yeah, sine is opposite. So you're going to set it up. So sine of 30 degrees, okay, like that is equals to the opposite, which is 2 over x, like that. And sine of 30 is a constant. And by the way, you can't just write sine equals to something. It's because these are all functions and they all take an angle with them. Like sine by itself doesn't mean anything. Sine of x would mean something. It's a sine function. But sine of 30 is a constant. It never changes. The value for sine 30 is 0.5. You can put that in a calculator. There we go. Now we're left with a linear equation. How do we solve for x?
You multiply by 2.
You multiply by 2 is wrong. Try again, because multiplying by 2 doesn't do anything on the right side. You'll just get 4 over x. It does not multiply by 2. Whenever the unknown is in the denominator, you want to multiply both sides by the unknown itself.
Okay.
So in fact, you need to multiply both sides by x. Always, when the unknown is in the denominator, multiply both sides by the unknown, because x and x cancels out. So we get 0.5x is 2. And then we would get x is divide both sides by 0.5, x would be 4, right? Now notice this is a right angle triangle. What if I wanted to find, I don't know, y? How do I go about finding this? I already know the two other sides. It's a right angle triangle. You want to use Pythagoras' theorem, okay? What does that say? It says c squared is equals to a squared plus b squared. So in a right angle triangle, a and b, it can be anything. It can be this or the one down. C has to be the hypotenuse. C is the longest side of the triangle. It's always going to be opposite to the 90 degrees. You can call this B. You can call this A, right? Right now we have A and C. We want to find B. So the formula for B would be C squared minus A squared first, and then you square root this. Okay? C squared minus A squared. So C for us is 4 squared minus A is 2 squared. That's 16 minus 4. That's the square root of 12. So this y down here would be square root of 12. Does that make sense? We can just do this actually. Let me just pull this up, because if you do an hour with me here, you should be set for, I don't know, and you guys take your sweet time in the class. How long did it take to do angles?
I don't know, they took like 2 weeks to do that.
All right, I don't care about that question. I don't care about this question. I do care about these. And here's some further info about SOH CAH TOAs. There exists a function. It's the reciprocal function. For example, you can have y equals to x, right? This is your linear line that goes like this. But then if you flip it upside down, you get y equals to 1 over x, which is the reciprocal function of x, okay? y equals 1 over x looks like this. Same thing applies to sine, cos, and tan. The reciprocal of sine is something called cosecant x, CSCX. Cosine, the reciprocal, is something called secant. I'm just going to write the full form. Cosecant. Cos, it's going to be secant. This is denoted by CSC. This is denoted by SEC. And finally, tan, the reciprocal of this is cotangent, denoted by COT. So what does this actually mean? Let's say I have sine 30, right, is 0.5. And cosecant is just like 1 over sine. Sec is 1 over cos. Cotangent is 1 over tan. Let's say I have sine 30 is 0.5. The question is, what is cosecant 30? All you do is you flip this, or you do 1 over that. So cosecant 30 is 1 over sine 30. So it's going to be 1 over 0.5. That's going to be 2. Okay? So these are reciprocal functions. What does it actually mean? Well, it means you flip it upside down, but it means something like this. Sine of x, we've done this in the past. It looks like this. Okay, this is a periodic function. It means it never ends. It's going to go forever to infinity on both the right side and the left side. Cosecant of x is just this thing flipped upside down. Wherever there's a 0, there's going to be an asymptote, because then you're going to be doing 1 over 0 when it flipped it upside down. And then it's just going to be a bunch of u's here. So cosecant x looks like this. U. You probably won't be graphing this anytime soon, but that's what that represents. It's just the flipped version of sine, flipped upside down, not to be confused with the inverse function. An example of that would be this: y equals to 1 over x squared. This is just your quadratic parabola, a u-shaped graph. Well, y equals to x squared is the u-shaped graph. The reciprocal of this is 1 over x squared, okay? But the inverse would be y to the power negative 1. Y inverse of x squared is plus minus square root of x. Inverse has nothing to do with the reciprocal. It's very, some people get confused with this. This cosecant is not the inverse of sine. Sine does have an inverse though. Every function has an inverse, but the inverse doesn't necessarily have to be a function. For example, y equals to x squared. The inverse of this is plus minus square root of x. So y equals to x squared looks like this. Plus minus a root of x looks like this. Is this a function, the one in green? Functions means you can only, well, if you draw a vertical line, it can only touch the graph once. This is not a function, okay? This is not a function, even though x squared is a function. Sine, cos, and tan, they also have inverse functions. It's called arctan. Well, for tan, it's called arctan. For sine, it's called arcsine. You don't have to worry about what graphing that looks like anytime soon, but it looks something like, it looks like this. It looks like an S, kind of. Okay, so sine looks like this. Goes on forever. Cosecant, which is 1 over sine, looks like this, upside down, flipped it. But then the inverse of sine, arcsine, looks like this. It's like an S. You don't have to worry about graphing it. That's just for you to know what's going on here. But these are the type of questions that you will see for sure. So we have a bunch of triangles. Notice all of them are right-angled triangles. If it's not a right-angled triangle, SOH CAH TOA fails. Let's look at A. Calculate cosecant, sec, and cotangent. Okay, so this one, we already started off with the reciprocal, but don't worry about that. Let's find sine theta, cosine theta, and tan theta for all of them. For I. It's just a visual thing. There's even no math required. IV, we're gonna find this for all 4 of them. So it's gonna be SOH CAH TOA. I'm gonna do the first one. I'm gonna do I. So again, theta is here. That means 6 is the opposite, right? Facing the theta, 6 is the opposite side. So sine of theta would be opposite over the hypotenuse, so it's going to be 6 over 10. Cosine is the adjacent. Adjacent is the side that's not the opposite. So for theta, this would be the adjacent, which means cosine would be adjacent 8 over 10. Okay, goes here, 8 over 10. Similarly, tan is going to be the opposite over the adjacent. So this is going to be 6 over 8. You can reduce them if you want to. Doesn't really make a difference. And there you go. That's all you have to do. SOH CAH TOA. Tell me for question 2, what's sine theta? And again, it's just a visual question. You just look at it. Sine is opposite, right? Look at where the theta is. It's going to be opposite. So opposite is 8.5 divided by hypotenuse. What's the hypotenuse?
12.
Yeah, exactly. Hypotenuse is always going to be the longest side. It is always going to be opposite of the right angle. What about cos theta? Cos is adjacent over hypotenuse. What's the adjacent side to theta?
Is it 8.5?
Yeah, it is 8.5 over 12. What about tan?
8.5 over 8.5?
Yeah, which is just a 1 and you're done, right? The third one, so opposite, so sine would be opposite over hypotenuse, so it's going to be 3 over 3.6. What's cosine theta? It'll be something, the adjacent over the hypotenuse.
So 2 over 3.6?
Yeah. Tan would be opposite over the adjacent. So 3 over 2, right? You want to do the last one? 4, what's sine theta?
8 over 17?
What's cosine?
15 over 17?
Right. What's tan?
8 over 15?
Yeah, that's all there is. Now this question is asking us to find the reciprocal. So it's very easy. Look at the first one. Sine, the reciprocal is cosecant theta. All you do is you take this guy and flip it upside down, literally like that. And there you go. Cosine, the reciprocal is secant theta, sec. You just flip that upside down, becomes 10 over 8. Tan is cotangent, cot theta. Flip it upside down, it's 8 over 6. What's cosecant for the second one?
12 over 8.5?
Yeah. And the next one will be 12 over 8.5 as well. And the last one will be 1 over 1. That's still a 1. This one, same thing. It's going to be 3.6 over 3, 3.6 over 2, 2 over 3. The last one, you flip it upside down, 17 over 8, 17 over 15, 15 over 8, and you're done. Okay? We're also going to find the angle itself. To find the angle itself, you're going to need a calculator. This is not doable by hand. Not for these numbers anyways. There's a specific set of numbers that you can do it in your head, but not for 6 over 10s. So you can use any of these to find the angle in the first question. You can use the sine, cosine, or tangent. They will all give you the same answer. So sine theta is 6 over 10, right? You're solving for theta. What you do is you take the sine inverse on both sides. You can also kind of think of this as dividing by sine, but that's not the technical way of thinking about it. So this becomes theta is sine inverse of 6 divided by 10. Do you have a calculator? Okay. So sine inverse is usually second function plus sine. You press second function sine, they'll give you sine inverse on your calculator, and you want to type 6 over 10 equals 2. Second function or shift or whatever you have. Sine and then 6/10.
It's giving me error.
But what does it look like on your calculator? Well, what's the input?
There's like the second function thing, and then there's sine like opposite to it.
All right, you need to put this in a bracket, 6/10. Sine inverse, bracket, 6/10.
It gives me 36.86.
There we go. So this angle here is 36.86. Now, if you do the same thing with cosine, try cos inverse of 8/10. It should give you the exact same thing because it's from the same triangle. We're looking at the same angle. Cos inverse of 8/10.
It gives you the same thing.
Yeah, and its tan would give you the same thing as well. Tan inverse of 6/8. It's because we're talking about the same angle. You can use any of the ratios. Okay. Here's an idea. I know why you got an error. Why did you get an error there? Because the input was this, right? The input was this. So the calculator is going to do this bit first. Sine function, sine of x, looks like this, okay? The domain, possible x values, x can be anything. X can be anything from -infinity to the y infinity, positive infinity. That's the domain. That's the possible x values it can take. But the y values that it can take, sine of x, it's strict. It's regulated. The upper bound is 1. The lower bound is -1. This is for both sine of x and cosine of x. Their domain, the x values, it can take anything. So it can take any angle, 1000, -10 million, anything. But the y value that it spits out is going to be strictly between 1 to -1. -1 to 1, I guess. The lower bound is always on the left. So when you do sine inverse of 6, it's trying to find the x value when the y value is 6 does not exist. That's why it gave you an error there. Okay, because it was not in the domain of the function itself. It was trying to, in a sense, it was trying to divide by 0. Does that make sense? And this is the real life application question, as you'll be seeing a lot of. So anytime you see a word problem, especially in trig, SOH CAH TOA Trig, try and make a quick sketch to see what's up. It'll give you a better idea. So there's a kite somewhere. Okay, this is the kite. It's 8.6 meters above the ground. So let's say this is the ground. That kite is 8.6 meters. And it is at an angle of elevation. Now, what does that mean, angle of elevation? There's two types of angles. Think of an eye, okay? This. And draw a horizontal line there. Angle of elevation is the angle that goes up like that, which is gonna be for us, let's say this is the eye, okay? This is the eye. It's gonna go up. It's gonna be right here, 41. There's something else called the angle of depression. Depression just means, well, it's not English. Mathematically, what depression means is like you're looking down. Things are going lower. Like there's a phenomenon called sea level depression. That doesn't mean the sea is sad, it just means the water level has gone down. The angle of depression would be this. So from the horizontal, like in this question, your angle of depression would have been this if they say the angle of depression. So two types of angle: elevation, looking up, always from the horizontal, not from the vertical. What do I mean by this? Like this angle, you see this angle is not the angle of elevation because we're not looking at it from the horizontal line. We're looking at it from the vertical line, so that won't be it. Same thing with the depression. This angle down here is not the angle of depression. It has to be from the horizontal. This one would be the angle of depression. Cool? Have you done something called Snell's law in physics?
No.
Probably not yet. Optics, have you gone to that part of science?
We're doing chemistry.
Okay, when you go to optics, you're gonna see something called Snell's law, and that thing uses the opposite. It uses the angle from the vertical. But this one is the angle of elevation depression is always going to be from the horizontal. So there you go, that's our setup. So there's our angle. We know our opposite side is given, right? It's opposite. What do you think the angle is right here? There's a kite here. There's a ground right here. What's this angle between this and this? What's this angle? It's perpendicular. Anything that's straight up is 90 degrees, like that. Okay. Anything that's straight up is going to be 90 degrees. So we know we have the opposite. What are they asking us? Calculate the length of the string. So are we looking for the hypotenuse or the adjacent length of the string?
It's the hypotenuse.
Right, so opposite given, hypotenuse we're looking for. Which one do we use? Sine, cosine, or tangent?
Do you use tan?
No, we don't, because we're interested in opposite and hypotenuse, right? It's gonna be sine. Right? Opposite and hypotenuse, the two parties of interest. It's going to be sine. So it's going to look like this. Sine of 41 degrees is equals to the opposite side, which is 8.6, divided by the unknown. We can call it x or whatever. How do we solve this for x?
You multiply by x.
Yeah. And remember, this is just a constant. So you can multiply by x on both sides. So you get x times sine 41 is equals to 8.6. Now what? You want to divide both
You
sides?
divide by sine.
Yeah, so 8.6 divided by sine 41. Try plugging this in as you see it. So 8.6 divided by, not sine inverse now, sine 41. Sine inverse, you would only use the inverse functions when you're trying to find the angle.
I got 13.108.
Okay, that sounds right. Let me double check that. 8.6 divided by sine 41. Yeah, so there you go. So x is 13.108. What's the unit?
Is it just meters?
Yeah, that's just meters. Nearest tenth. What does that mean?
You round it?
2. How many decimal places?
Just one?
Yeah, so this should be 13.1 meters. So that's the length of the string, okay? And a quick verification, this has to be longer than the height, right? Because it's the hypotenuse, which it is, so I guess we've done it right. That makes sense?
Mm-hmm.
You want to do a more difficult one? The two guy wires. That's just a type of wire. It's a very strong, like, wire made out of metal. It's supporting an antenna. Okay, so let's say this is the antenna. It is 8.5 meters in height. And it forms an angle of 55 degrees with the ground. So let's say this is the ground. And can say, so there's multiple ways to do this. It's because here's one way to do this, because we don't know if the wires are on different sides, right? This could be case one, or there's one wire. But then here, this could be case two. Which one is more logical?
The second one.
Yeah, the first one, it'll probably like pull this and this will tilt over, right? So the second one is, I think, is better. So, and then what else is going on? The wires that are attached to the antenna, 3.71 meters above the ground. Calculate the length of each wire to the nearest tenth of a meter. All right, so a lot of things going on here. The wire, there's a wire, but it's a little bit, it's at a height of 3.71 meters above the ground. The height of this was 8.5 meters, and then there's another wire on this side, which is also 3.71 meters above the ground. And it's supporting it like this, right? And it's making an angle of 55 degrees from the ground. So if it's like this 55, that means if you raise it a little bit higher, this angle should also be 55. Do you agree? If this is 55, you just move it a little bit higher. This angle is going to be the same thing as this angle. Because these two lines are parallel. You remember this? If these two lines are parallel, then whatever this angle is, this angle has to be the same. So I can just do it like this. So this is going to be 55. This is going to be 55. Right? If the whole thing is 8.5, that's the whole length of the antenna. What's the distance from here to here?
You subtract.
Yeah, you would subtract. So it's going to be 8.5 minus 3.71 meters. That's going to be 4.79. So this is 4.79. And again, this something raised up is going to be perpendicular to the ground, right? Because it's directly above the ground. It is going to be perpendicular. And we can just erase everything else that we don't need. So we don't need that. We don't need any of these things. There you go. That's our setup. What is the question asking us? It's asking us to find this length, right? And this length. You can use either triangle actually because they're identical. You can even erase one half of the triangle completely. You can just look at this. Tell me, is this sine question, cosine, or tan? Look at what we're given and look at what we're trying to find. Which side are we given relative to the angle?
We're given the opposite.
Yeah, we're given the opposite. Which one are we interested in?
Hypotenuse.
Yeah, so which one uses opposite and hypotenuse?
The first one.
Yeah, so this is going to be our setup. Sine 55 is going to be equals to 4.71 divided by x. We've done this a few times. Multiply both sides by x and divide both sides by sine 51. Try plugging this in. Sine 55, sorry. 4.71 divided by sine 55. And tell me what you get.
I get 5.75.
To the nearest tenth. So 5.7 meters. And you're done. Okay? So that's the length of the wire. What assumption did you make? Well, we assume that the wires are on opposite sides, right? We said one was here and then one was here. And then we also assumed that the tower, whatever this is, the antenna, whatever this is perpendicular to the ground. Otherwise, we can't use, this is a very important assumption. The first one is whatever. Second one is important. The tower is perpendicular. If it was slightly slanted, then we would not have been able to solve this using SOH CAH TOA. We could solve it using sine law and cosine law. which I don't know if you remember. This is for non-right angle triangles, like maybe something like, yeah. So this is angle A, this is angle B, this is angle C. Opposite to all of these would be their small letter. Same thing, like B becomes B here, small letter, A becomes A here, C becomes small letter C. Sine law says sine A over A is equals to sine B over B is equals to sine C over C. You don't use all three of them at the same time. You're either going to use A and B or A and C or B and C or C and A. You're only going to use two of them at a time. And this one you're going to use when you're given a triangle that is not right angled. Okay? This works. If it's not right angled, then SOH-CAH-TOA fails. That's an important distinction. And then you don't always need a calculator to do these things, but it's very restricted. There's only certain values that you can kind of do it without using a calculator. And they will ask you, they'll be like, find the exact value of sine 45. This will be the question. Find the exact value of sine 45. Plug it in the calculator, it is going to give you an irrational number. So that number is not the exact value because we don't know where the decimal ends. Well, it never ends actually, so that won't be the exact value. That will be the calculator value. The exact value, you need to write it in terms of a radical, a root. So now how do we do that? All right, so this is where we come with the idea of special triangles. There's two triangles that we can use. In fact, those are the only two triangles that exist for which we don't need a calculator, for which we can find an exact value. The first one is 30-60 triangle, and both of these are right angle triangles. So let's look at this. So there's a triangle that is right angled, okay? One of the angles in the triangle is 30, the other is 60, like that. And then we need to build this triangle. And there's gonna be a trick to drawing both of these triangles. The other triangle is called 45-45. So it's gonna look like this. There's a right angle, and it's an isosceles triangle basically because two angles are the same. Okay, like that. So how do we build this? We're gonna need the side, by building it, I mean finding the side lengths of all three. They're always gonna be the same. For the 30-60 triangle, you want to remember that sine 30 is a half. What was the formula for sine, if you remember? What over what is sine? So, right? What over what?
The opposite over the hypotenuse.
Right, so this thing is opposite over the hypotenuse. What does that mean? That means opposite to 30 degrees, because the angle is 30. The length of that side is 1. Hypotenuse of the triangle is 2 units. There we go. So that's the trick there, to remember that sine 30 is 1 over 2, which is a half, and that is equals to the opposite over the hypotenuse using SOH-CAH-TOA. How do we find the missing third side? It is a right angle triangle. We know two sides. We're missing the last side. What do we use? I'm gonna use Pythagoras, right? Two sides of a right angle triangle are done. So this is C, this is A, this is B. So we have C squared equals A squared plus B squared. Subtract A squared from both sides. So C squared minus A squared is B squared. Take the square root on both sides. B is gonna be C squared minus A squared, the square root of it. Okay? in other words, you can even write this like this. So you have 2 squared, that's c squared, that is equals to 1 squared, that's a, plus b squared. How do we solve for b?
You subtract 1.
Yeah, so 4 minus 1 is 3. 3 is b squared. What is b? What do we do on both sides?
Square root.
Yeah, so b is going to be the square root of 3. Plus minus, but because we're talking about the side lengths of a triangle, length will always be positive. It's the distance. So that means the bottom side of this triangle is going to be root 3. And there we go. And look at how powerful this is, because this kind of gives us a lot of things. Sine 30, the opposite. Well, we knew this is how we built this. It's 1 over 2. What is cosine 30? Just use SOH CAH TOA. Again, no math required, just a visual question. Cos 30 means cos is adjacent over the hypotenuse.
Square root of 3 over 2.
Yeah. What is tan 30?
Square root of 3 over 1.
No, tan 30 opposite over the adjacent. So it's going to be 1 over square root of 3. Right? Opposite over the adjacent. Adjacent is the side that's not the opposite. Similarly, we can find sine 60 as well. We can find the 60-degree values. Look at 60. Now you got to look at it this way, because 60 is the angle of interest. The opposite side from 60 is root 3, right? Hypotenuse, again, it's opposite over the hypotenuse. Hypotenuse never changes. It's going to be 2. What is cosine of 60?
1 over 2.
Yeah. What's tan of 60?
Square root of 3 over 1.
Right, and that's just square root of 3. And there we go. These are the exact values. If you plug cosine 30 in your calculator, it'll probably give you 1.67 or something. A decimal. And in fact, it'll give you an irrational number, but this would be the exact value. Similarly, we can build a 45-45 triangle as well. So the trick for the first one was to know that sine 30 is 1 over 2, which is opposite over hypotenuse. And you can find b using Pythagoras theorem. Same thing here, 45-45. The trick is to know that both of these side lengths are 1 units each. Okay, 45, it's an isosceles triangle. They're the same, it's 1 unit. What would be the hypotenuse of that triangle?
Wouldn't it just be 2?
No, it would not be. C squared is a squared plus b squared, right? C squared is 2. What's c?
Square root of 2.
Yeah, square root of 2. There we go. And using this, we can write down a bunch of ratios. Sine 45, again, it doesn't matter which angle you look at it from because they're both the same, so you can use either one of them. Opposite from both of them is still 1, and the hypotenuse is root 2. What's cosine of 45?
One over square root of 2.
Yep. What is tan of 45?
Just 1.
Yeah. And you're done. There we go. Special triangles. 2 of them gives you 9 different ratios. You can even flip them, right? Like, what if I asked you, what's cotangent of 60? Cot is 1 over tan. So you're going to look at tan 60. It's root 3 over 1. You're just going to flip it upside down. Cotangent of 60 is 1 over this guy. So it's going to be 1 over root 3. What is cosecant of 45? Cosecant is the reciprocal of sine.
Square root of 2 over 1.
Yeah. What's cotangent of 45?
It's 1.
Yep. And there you go. That's how you can get a bunch of things from these. In fact, it'll give you 18 different ratios from the two triangles if you take into account the secant, the cosecant, and cotangent. These three, the flipped ones, the flipped versions, are called the secondary ratios. Whereas the main ones, sine, cos, and tan, these are called the primary ratios. Okay? You can only get the secondary from the primary. And there we go. That's the special triangles. And you're going to use it when they ask you to find the exact value. Like, wait, I'm going to show you a question here, right here. Determine the exact value of these guys. So if you plug this in a calculator, it will give you some irrational number, which doesn't help you. I'm going to give all of them to you right now because we just built it from the triangle. Or actually, I'm going to give you the triangle. 1, 1, root 2, 45. And eventually you're going to end up like remembering this if you do enough questions on this. 30, it's 1, 2, this is root 3. 60, boom. All right, what's sine of 45? Look at the triangles. Sin of 45. It's not sin. Some people say it's sin. No, it's sine.
Is it 1 over square root of 2?
Yeah, it is. What about cosine 45?
It's
Right?
the same.
Yeah, SOH CAH TOA, right? It's gonna be the same. Times 1 over root 2. What's sine of 30?
It's 1 over 2.
Yep. What is sine of 60?
Square root of 3 over 2.
Yeah. 1 times 1 on the numerator is still a 1. What's root 2 times root 2?
Is it root 4?
Yeah, it is, which is a 2. So basically, root a times root a is straight up just a, because the root cancels out, okay? It is root 4, which is 2. For example, root 6 times root 6 is straight up a 6. You can just kill the root. So root 2 times root 2 is just a 2. What about on the other side? What if you multiply the numerator and multiply the denominators together? What do you get?
Square root of 3 over 4.
Yeah. Now let's take the LCD. What's the LCD between 2 and 4?
It's 4.
It's 4, so you need to multiply this guy by a 2 here, by a 2 here. So you get 2 plus root 3 on the numerator, and you combine them 4. There you go. That's the exact value of this expression. And the fact that there's a root 3 here, which is an irrational number, we know the calculator wouldn't give this to us. Okay? That's how you do these types of questions when they ask you for the exact values. And they've given us this handy chart here, which we're going to use. Just to hammer this idea home, let's try doing some of these. And we don't need to draw the triangle because, like, how do you read this chart? Like, so cosine of 30 is root 3 over 2. Tan of 60 is root 3, see? Sine of 60 is root 3 over 2. So that's how you would read it. Let's do A. What's sine of 30?
It's just 1 over 2.
Yeah, what's tan 60?
Root of 3.
Minus cosine 30. What's cosine 30?
Root of 3 over 2.
Yep. If you multiply the first two, what do you get?
Root of 3 over 2.
Yeah. So root of 3 over 2 minus root of 3 over 2, not a 0. 1 and done. And it just kind of goes like that. Look, it's very quick actually. Like be 2 times cosine 45, I can see from the chart, is root 2 over 2. They have just rationalized the denominator. Look at this. If we write this as root 2 over, because we know 2 is just root 2 times root 2. This cancels out with this, and you get 1 over root 2 is what we had before. But if you want to rationalize this, you need to multiply by the conjugate, which is going to be itself here. And you end up getting root 2 over 2. So this is just the rationalized version of 1 over root 2 that we had from the triangle. You can use both. They will both give you the same answer. So cos 45, I'm just going to use the one they have here. Root 2 over 2 times sine 45, which is also root 2 over 2. What do you get if you simplify this expression?
Two over 4.
So the 2 and 2 would give you a 2, so you'll get 2 times 2 over 4, right? 4 over 4, and that'll be 1. And just like that, you're done.
Okay.
Good so far with this, SOH CAH TOA? I want to do C because C has a weird symbol there. Tan squared 30 just means you take tan 30 and you square it. So for C, tan squared 30. Tan 30 is root 3 over 3. We're going to square it minus cosine 45 squared. You take cosine 45, which is root 2 over 2, and then you square it. Okay? There's a difference between tan squared 30 and tan 30 squared. Tan 30 squared just means tan of 900. Whereas tan squared 30 means you do tan 30 first and then you square it. What's root 3 over 3 squared? This squared is going to apply to both of those guys.
Is it just root 9 over 9?
Yeah, that's what it is. So root 9 is 3, so you get 3 over 9. What about on the other side?
Two over 4.
Yep. What's the LCD between 9 and 4?
Is it just 36?
It is. And multiply this by 9, multiply this by 4. A quick way to finding the LCD is you just multiply the numerators. You have to check for that. Half of 30, multiply them, you get 36. 18 doesn't work for 4, so it is 36. So you get 12 minus 18 over 36, so you'll get negative 6 over 36, which is minus 1 over 6, and you're done. Okay? So yeah, that is how you would do special triangle questions. But then sometimes they're gonna ask you to flippity flop. Like here, notice the angle is missing, right? I'm gonna give you the chart. The chart is gonna come very handy, and they may not give you the chart on the tests. You may have to draw the special triangles, but again, which is takes 10 seconds. Right? Special triangles, it's not that like bad. Like 45 1 is 1 1 root 2, 45 here, 45 here. The other one 30 61 30, opposite is 1, hypotenuse is 2. That means down there is root 3. So it doesn't take too long to build it. But yeah, the chart is always gonna be handy. So now the angle is missing. Notice the angle is missing. So sine theta is root 3 over 2, okay? Find root 3 over 2 first, and the angle will be, well, theta would be the angle. So for A, theta is simply 60 degrees. I'm trying to find the angle. For B, root 3 tan theta is 1. What you want to do is for all of these, when the angle is missing, you want to solve for sine theta, cosine theta, or tan theta. You just want to have tan theta on one side of the equation. That means you need to get rid of that root 3. How do we get rid of that root 3? What do we do on both sides?
You divide by root 3.
Yeah, you divide both sides by root 3. So you get tan theta is 1 over root 3. So what is theta? Actually, we need to rationalize this. How do we rationalize 1 over root 3?
Do you multiply by root 3?
Yeah, you're going to multiply by root 3 on the top and the bottom. So times root 3 times root 3. So what do you get?
Root 3 over 3?
Yep. So what's theta? If tan theta is root 3 over 3, what's theta?
It's 30.
And you're done. Easy. What about C? Again, we need to get rid of this guy. What do we do on both sides?
You divide.
By what? The whole thing, right? You get 2 over 2 root 2. This cancels out, so now we have cos theta is 1 over root 2. Let's rationalize this. What do we multiply that by?
Root 2.
Like that. So you get cos theta is root 2 over 2. So what's theta?
45.
Yeah, and just like that, you're done. So from here to here, what we did was we did cosine inverse on both sides. Cosine inverse of root 2 over 2. And you can also do this bit in a calculator if you don't have the chart. And that's going to be 45. And you are done. Notice how the value for sine 45 and cos 45 is the same. See this? Sine 45 and cos 45 is the same. So what is happening there? This is what's happening. Think of a circle with the origin, with the center at the origin, okay? This is the center of the circle. The radius of this circle is 1. And we're gonna draw a triangle at 45 degrees, okay? Like this. The point where it meets the circle there, that is given to you by cosine of x, comma, sine of x. Cosine is always the x value, sine is always the y value. So at that point, it's diagonal, right? Whatever the x value is, the y value is the same because it's at a 45. 45 means it's perfectly diagonal. Because this is 90 degrees, 45 is gonna cut it exactly in half. So at that point, at 45 degrees, both the x and the y value of the circle is the same, right? Over here. Over here, it will also be the same, except the y value is positive. The x value will give you a negative x value, but the y value will be positive. But numerically, they're the same. What about down here? They're both negative, right? So you get some negative x value, some negative y value. It's cutting it in half, so they'll be exactly the same. Same thing here, but over here, the x is positive, the y is negative. Because this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And this kind of gives us the CAST rule, C-A-S-T. Remember that? It's okay if you don't. CAST rule just says in quadrant 1, everything is positive. A is for all, so all positive. Quadrant 2, only sine is positive. Quadrant 3, only tan is positive. Quadrant 4, only cosine is positive. And you're gonna need to use this rule if they ask you to find values beyond 90 degrees. For example, if they ask you to find tan of 300 degrees, you're gonna have to find you're gonna have to use the cast rule. Okay.
Okay.
All right. Let's call it a day there.
All right. Thank you.
See ya.